Hello students. Now in our next lecture in general organic chemistry, in which we are discussing the basic concept from organic chemistry. Now today we are discussing the classification of organic compounds on the basis of the functional group. So before we are discussing the classification of the organic compound on the basis of the functional group, first we define what is functional group. So what is functional group? So when you consider any organic compound contain the two part. One is the hydrocarbon plus functional group. Organic compound is made up of the two part. One is the hydrocarbon plus functional group. Suppose I consider example as a CH3 CH2OH, that is ethyl alcohol. So in ethyl alcohol, this ethyl group contain carbon and hydrogen, so it is a part of hydrocarbon, and this OH is a functional group. Suppose I consider example as a ethyl bromide. In ethyl bromide, ethyl is a hydrocarbon and bromine is a functional group. If I change the functional group, the organic compound can be changed. Suppose I consider acetaldehyde. In acetaldehyde, this methyl is a hydrocarbon and this aldehyde group is the functional group. So like this way, when you consider a functional group, so how we define the functional group? So functional group is an atom or a group of atom. It may be the atom or group of atom which can determine the characteristics property of that compound. Means if the functional group changes, that organic compound can be changes. So whatever the property that belongs to this organic compound is due to this functional group. So functional group is an atom or a group of atom. I write the definition. Functional group is atom or group of atom which determine properties, or you can say it, which decided properties of organic compound. So that group or group of atom called it as a functional group. So let us consider the classification of the organic compound on the basis of functional group. So class of compound, first we consider, then functional group, representation of organic compound, and then we consider examples. So let us consider the class of the compound is first halide. In halides, the functional group is a halide. Halide is denoted as X, where X may be the fluorine, chlorine, bromine or iodine. So these are the halides. Fluorine, chlorine, bromine, iodine. So how this, if the X is belong to the any organic compound, so these organic compound represented as a hydrocarbon R and halide X. So example, if R is a CH3 group, it is called as methyl chloride if the halogen is a chlorine. Methyl bromide, methyl chloride. I write the name methyl chloride. methyl bromide or ethyl iodide. C2H5 is ethyl, so it is a ethyl iodide. So like this way, the halide containing organic compounds are called as a RX, that is the alkyl halides. They are called as alkyl halides. Now second is the cyanide. Second is the cyanide. The cyanide has a functional group CN. Carbon is having the 4 valency, so 1, 2, 3, 4. Nitrogen is having 3 valency, 1, 2, 3. So cyanide can be represented like this way. If the cyanide is belong to organic compound, that is represented as RCN. That is a alkyl. R for alkyl, CN for cyanide. So alkyl cyanide. For example, R group is a CH3 and CN is attached. It is called as methyl cyanide. Or cyanide is also called as nitrile. It is also called as nitrile. So remember. So when we use a IUPAC name, then we use that CH3 CH2 CN. So it is called as ethyl cyanide. It is called as ethyl cyanide. So this is the second functional group. Third is a isocyanide. Isocyanide. So if C and N place will be changes, it is called as isocyanide. In isocyanide, nitrogen is having 4 valency, so which is excess. So I show with the positive charge. Carbon is having 1 valency less. I show with the negative charge. So if the R is attached to Cn, it is an alkyl cyanide. If R is attached to Nc, it is called as a alkyl isocyanide. So it is a alkyl isocyanide. So suppose an example is a C2H5 NC. It is called as ethyl isocyanide. If it is a CH3, it is called as methyl isocyanide. So like this way, look at. So when I consider the halides, they are represented as alkyl halides. When I consider cyanide, they are called as a alkyl cyanide. When I consider isocyanide, they are called as a alkyl isocyanide. The next group I consider is the nitroalkanes. Nitroalkanes. Nitro, NO2 is a nitro group. The functional group is a nitro. Oxygen is having 2 valency, so this is negative charge. This oxygen is having 2 valency, negative charge. This nitrogen is having the 4 valency, so I place the positive charge because 1 valence is extra. So RNO2. So they are called as nitroalkanes. They are called as nitroalkane. If the R is a CH3, so CH2 is a methyl. So it is a nitro. So here the name is given in the form of the alkanes. So methane CH4. If the one hydrogen of the methane is replaced by a nitro group, so I get nitromethane. So name of this given compound is given in the form of the alkane, nitromethane. Because nitro group is considered as a substituent, so therefore its name is given as a nitromethane. C2H5NO2 is called as nitroethane. It called it as a nitroethane. So like this way, this 4 class of the compounds we consider. Okay. Now next class of the compound is the alcohol. Next class of the compound is the alcohol. Next class of the compound is alcohol. So when I consider alcohol, alcohol is having functional group as a OH. This functional group is called as hydroxyl OH group. They are represented as ROH. That is, so this is a methyl alcohol, ethyl alcohol, so like this way. So it is a alkyl alcohol. So they are the alcohols. They are alkyl alcohols. For example, CS3OH. So it is a methyl alcohol. C2H5OH. It is the ethyl alcohol. Okay. Next is the phenol. So when I consider phenol, phenol is an aromatic compounds because when benzene is ring is attached to OH, they are called as phenol. So benzene ring is represented as C6H5. Look at C6H6 is the benzene. Benzene is having 6 carbon, 6 hydrogen like this way. So if the carbon is having the 6 hydrogen and having the 3 double bond, it is a benzene. If the one hydrogen is replaced by OH, when one hydrogen is replaced by OH, so this C6H6, I can write C6H5 and one hydrogen is replaced by OH, so this group is called it as a phenol. So phenols are the aromatic compound in which Ar is the aromatic. Ar is for aromatic. Ar is for aromatic. So in aromatic, Ar is represented and OH group is attached. So AROH I can same as written as C6H5OH. So representation of the compound is the same, C6H5OH. So it's only example, and this C6H5OH means aromatic OH are called it as a phenol. So representation is a AROH, aromatic hydroxy. These are the phenols. Next class of the compound is the aldehyde. Next class of the compound is the aldehyde. So aldehyde have the functional group, that is a aldehyde functional group, RCOH. This is a aldehyde functional group. Now representation is a RCOH. These are the example for aldehyde. So if R is a methyl, it is called it as a acetaldehyde. Remember, acetaldehyde, it's a special and common name. It is not called as a methylaldehyde, it is called as acetaldehyde. If at the place of the CS3 you have to write H, it is called as a formaldehyde. Formaldehyde. So like this way, the names are given. Formaldehyde obtained from formica. So therefore its name is given as a formaldehyde because formaldehyde is obtained from formic acid. Formic acid. That formic acid is obtained in red ants. Acetaldehyde is obtained from acetum. Acetum means vinegar. Acetum means vinegar, and therefore its name is given as a acetaldehyde. Next class of the compound is the ether. Is the ethers. In ethers, the functional group is a like this way. So what is this functional group? So this R with O and R. If the hydrocarbon part we remove, then what is the functional group? You can put it is ether. So ether have, you can say this linkage where carbon I can write with the 4 valency, it represents R. So ROR or COC is the ether. So if I write the value of R, CS3, O, CS3, or if you consider C2H5, O, C2H5, then both are the ethers. Now this CS3, these two groups are the same. So they are the two and therefore di. So I call it as a dimethyl ether. These two groups are ethyl, so they are called as a diethyl ether. So like this way, this class of the compound is represented are the ethers. Okay. The next class of the compounds are ketones. Next are the ketones. So functional group for the ketones are C double bond O. These are the ketones functional group. They are represented as RCOR. When the two R are attached with the CO, this group is called as a carbonyl group. This group is called as a carbonyl group. Okay. For example, I write CS3, CCS3. So name of this compound is a dimethyl ketone, or also called it as acetone. Also called it as acetone. Next is the carboxylic acid. Next is the carboxylic acid. Carboxylic acid has a functional group COOH. I can write it COOH. So carbon is with the 4 valency and oxygen with the 2 valency and hydrogen is a monovalent. So like this way I can represent a carboxylic group. Example RCOOH. If I place the value of R as a CH3, it has a total carbon as a 2. So its name is a acetic acid. Its name is a acetic acid. Remember, acetaldehyde is obtained from acetic acid. Similarly, formaldehyde is obtained from formic acid. So this is the formic acid from which formaldehyde is obtained. Acetic acid from which acetaldehyde is obtained. So therefore I can write its name as an acetic acid. So at the place of the methyl, if I place COOH, it is the formic acid. It is a formic acid. Formic acid is obtained from formica. Acetic acid is obtained from acetum. Formic acid obtained from formica. Okay. So this is a carboxylic acid. The next class of the compound is the ester. Next is the esters. So esters are represented as COO. Okay. R COOR. Both are maybe same or maybe different. Suppose CS3CO OCS3 or CS3CO OC2H5. Both are the example of the ester. So in this example, suppose this group is obtained from acetic acid. This group is obtained from acetic acid. Acetic acid CH3COOH. If this hydrogen is replaced by methyl, you get methyl acetate. This acetic acid gives acetate. So therefore its name is methyl acetate. Because one hydrogen is replaced. So it is a methyl acetate. If hydrogen is replaced with the ethyl, it is called as a ethyl acetate. Remember, the group which is obtained by replacement of one hydrogen from acetic acid is called it as a acetate. So its name is given as a methyl acetate, ethyl acetate. So acetates are the ester family. Next are the amines. Next class of the compounds are the amines. Amines have the functional group NH2. Representation are RNH2. Where R is a methyl, it is called as a, so when R is NH2, they are called as a amines. They are called as amines. So its name is a methyl amine. R is a CH3, so it is a methyl amine. So methyl amine. So methyl amine is also one of the class of the compounds. So amines are further classified as a, so when I consider RNH2, RNH2 is the primary amine. RNH2 is the primary amine. Okay. So amines I consider as a secondary amine. Secondary amine. So this is the primary amine. Then I write secondary amine, just like the functional group for this. When I consider secondary amine, the one hydrogen at the place of NH2, one hydrogen I place R group. Okay. So there is only, so like this way. So when When you consider primary amine, only one R group is there. In the secondary amine, there are the two R group are there. So representation is R, N, H, secondary amine. So here the valency of the nitrogen is written like this way. If I consider next is a tertiary amine. Tertiary amine. What happened in tertiary amine? All the valency of the nitrogen are satisfied with the alkyl group. So it is a tertiary. Here there is only one alkyl group, so it is a primary amine. When there are the two alkyl group, it is a secondary amine, and when there are three alkyl groups, then it is a tertiary amine, because all the valency are replaced with the R groups. Okay, so secondary amine, I can write example for secondary amine is a, suppose methyl and methyl H. They are called as a dimethyl amine. If the three R groups are methyl, I write N, CS3, CS3, CS3. They are called as a trimethyl amine. So like this way, the primary, secondary and the tertiary amines are considered. Look at this, is also called as a primary amine. Primary amine. In primary amine, the NH2 group is attached to only one R group, because the valency of the nitrogen is a 3. So out of the 3 valency of the nitrogen in primary amine, the 2 valency is satisfied with the 2 hydrogen and only one R means why it is a primary? Because out of the 3 valency of the nitrogen, 1 valency is satisfied with 1 carbon and 2 with the 2 hydrogen. In case of the secondary, out of the 3 valency of the nitrogen, the 2 valency are satisfied with the carbon and 1 valency is satisfied with only 1 hydrogen. So therefore 2 R, so it's secondary. So here the 3 R group, 3 carbon, out of the 3 valency of the nitrogen, all the 3 valency are satisfied with the carbon. So these are the tertiary amine. So like this way, the amines are classified as a primary, secondary and tertiary amines. Now the next class of the compound is the amide. Next class of the compounds is the amide. So amides, CONH2, this group is called as a amide group. For example, it is represented as RCONH2. If R is a CH3, it is called as a CS3CONH2, called it as acetamide. So the amide can be also a primary amine, secondary amine and tertiary amide. What happened in the secondary amide? In secondary amide again, this nitrogen, on the nitrogen, one R group is there, then it is a secondary amide. So this is RCON. Out of the 3 valency, the 2 valency is satisfied with the hydrogen. Now one R is there. So this is a secondary amide. What happened in the tertiary amide? Next is the tertiary amide. In tertiary amide, CON, this hydrogen is also replaced with the R group. So therefore, this tertiary amide is having this type of the groups. Look at amides, RCONH2. Secondary amide, RCONH. One R on the hydrogen is replaced. So it is a secondary amide. If both the R will be replaced, because all nitrogen valency is satisfied with the 3 carbon. The 2 valency of the nitrogen is satisfied with the 2 carbon, and the 1 valency of the nitrogen is satisfied with only 1 carbon. So it is a primary amide, it is a secondary amide, it is a tertiary amide. So I write the example of the secondary amide: CS3CONHCS3 or CS3CONCS3 and CS3. So how we write the name of this compound? Remember, CS3CONH2 is the acetamide. Now one hydrogen is replaced by the methyl, so it is called as a, now this replacement is on the nitrogen, so it is called as a N-methyl acetamide. It is called as a N-methyl acetamide. If there are the two methyl group on the nitrogen, they are called as a N dimethyl acetamide. It is called as a NN. Though two there, two are NN dimethyl acetamide. Look here, acetamide. When there is a methyl groups are there, so methyl acetamide. It is a N-methyl acetamide. It is a NN because the replacement is on the nitrogen, so it's called as this replacement is a 2. So therefore, I can write the nitrogen in the 2 way, 2 time NN dimethyl acetamide. So this class of the compound is also considered. Next class of the compound is the anhydride. Next class of the compound is the anhydride. So in the anhydride, the functional group is like this way. Representation is that RCO, OCOR. So suppose at the place of the CS, I can write CS3CO, COCH3. Okay. So remember, how the anhydrides are obtained? Anhydrides are obtained by removal of the anhydride. The water molecule, when I remove, what are the compound you obtained are called as anhydride. Suppose I have the two molecule of acetic acid, CS3COH. From this acetic acid, if I remove the water, then whatever the obtained next is the anhydride. So acetic acid gives acetic anhydride. So this is the acid anhydride.